In this video, we'll be discussing about input and output operation in Python. First, let us see about input operation. Now, using input operation, the program can accept a value or a data from the user through the keyboard. It makes the program more interactive. For example, if you write a program to add two numbers, you can make it more interactive by asking the user to enter the two numbers, and then your program will add those two numbers and give the result back. Now, to get the values from the keyboard to your program, Python uses input function. So here you can see it is used for accepting input into the program. It accepts all values from the keyboard as a string. So you should understand this very clearly. Whatever you enter from the keyboard is read as a string into your program by this function. Now the input function will terminate data entry on pressing the enter key. So if you want to enter a big number, you can enter 2, 3, 5, 6, 7, 8, 9, all the digits that you want. And finally, when you have to make this entry into the program, you have to press enter. Okay, so this big number will be read from your keyboard by input function and moved into your program's memory. So now let us continue. Now let us see some example of input. If you write this statement inside your Python program, now we have called the function input. So when the interpreter reaches this particular statement, now the program will stop execution, and then Python is expecting the user to type an input. So if the user type in the keyboard India and press enter, the value India will be copied to variable country by your function input. Now in the next statement, you can see I have put a sentence inside the input function. When Python interpreter runs this function input, you will see this entire sentence, enter your country, onto the terminal. Okay, and after that you have to make your entry. So now the user will type India over here, and then the value India will be copied into the country. So here the advantage is that the user will exactly know what he has to enter, because the program already told him you have to enter your country name, right? So then he has entered India, it got copied into variable country. Now we have already seen in the previous slide, everything that is read by input function will be converted to a string and loaded into the variable on the left side. So now you can see if you check the type of variable country, it is coming as a string. Now in the next example, we will see how to read a number. Now you can see in this input function, I am printing enter your age, and after that you can make your entry. So once this statement is executed onto the screen, you will see Python will print enter your age with a colon. Why? Because we have given a colon over here. And after that, the interpreter is expecting the user to enter something. So I have entered 16 over here. Now this 16 will be copied into age, but we have a small problem because we already discussed that input will read everything as a string. So the value 16 will be loaded into age, but it will be loaded as a string. That is why you can see here, when you are trying to find out the data type of age, even though we have stored a number into it, you can see it will come as a string. So we have a different way to convert this string 16 to integer 16 and then load it to age. We will see that later. So now let us continue. Now next we are going to study about output operation. So output operation is used to display the output or result of your program onto the monitor, okay, or onto the screen. Now the function used for output operation is called print function. Print function will write or print the output onto the screen. Now the print function always ends with a new line. For example, if I ask the print function to print a string called hello, so what happens in the output is that it will print all the characters in hello, and then the control will be moved to the next line. So that is what we are discussing here. Print will always end with a new line, and that is the default. If you don't want that to happen, which means if you want the cursor to be in the same line after the printing is finished, you can always use this keyword end to change the default behavior. Okay, so that's the next point. Now you can call the print function to print the value, and after that you can put a comma and specify what will be the end character. Okay, so by default it is new line, so the control goes to the next line, but you can change it over here. So by using this end keyword inside print, you can change the end of print anything other than new line. So you can see this example over here, print hi, and I'm asking that this print statement should end with a space. Okay, so this will print HAI, then a space will be printed. After that, the cursor will wait on the same line. Now let's see the first example. Now I'm asking Python to print have a good day. So it will just print everything that we have given inside the codes. What we have written inside, the same thing will be printed outside. So you can see have a good day will be printed. Now in the second example, I am creating two variables a and b with value 10 and 20. After that, I am calling print. Now I told you everything you put inside quotes will be printed as such. So sum equal to will be printed just like that. Okay, and after that you can see you put a comma and then you have something which is not inside the quotes. So if you write something without giving the quotes, then print will actually print the value of those variables. So here you know that the value of a is 10 and value of b is 20. So before the actual printing happens, I have to add them. So I will add 10 and 20. The result 30 will come over here, and after that print will output the value 30, and that's why the output comes like this. Now in the third example, you can see I have used a concatenation operator plus to combine two words good and luck. Now before the print statement starts its operation, first you have to finish the concatenation operation. Alright, so it will combine these two words together. Good luck as one single word will be created, and after that print will print it to the output. So you can see over here. Now in the next statement, you can see there is a comma operator. This is how you can separate different values inside print function. So this will not combine good and luck. So now this print statement will pick the first value good. It will be printed out. Now you have a comma, and then it will take the next value luck and it will be printed out. So you can see automatically a space is put in between them. Now in the last print statement, you can see I have a combination of string, variable, then a string, a variable, string, then an additional operation with two variables. So let us see how this print function will print this output. So you can see the first value inside print is put in quotes. So whatever you write inside will be printed as such. So sum of will be printed. Now you have a without quotes. So the value of a will be printed. Okay, so here you can see the value of a is 10. So 10 will be printed. After that, you can see and is put inside quotes. So whatever you write inside that, it will be printed as such. So and will be printed. After that, you have b without quotes. So the value of b will be printed, which is 20. After that, you have is in quotes. So is will be printed. Now you have a plus b without quotes, right? So now the value of a will come over here and value of b will come. It will do the mathematical operation. The value will be resolved. 30 will be identified, and now print will output the value 30. Next, we are going to study about type conversion. Okay, now what do you mean by type conversion? That is changing the data type of a value. So if you want to change an integer to a string, or if you want to change a floating point value to an integer, or if you want to change a string to an integer, then you can use this type conversion function. Now there are two types of type conversion that is defined inside Python. The first one is called explicit type conversion, that is done by us, by the programmer itself. And then the second type is called implicit type conversion. This is done by interpreter in the background. So the programmer doesn't have to know this type conversion actually happened. In this example, we will see why we require a type conversion. Okay, or why we have to change an integer to string or string to integer, right? We have an example here. When we go through this, you will understand we have to change the type. My aim is to read 2 marks. Okay, I have to read the mark of physics. I have to read the marks of mathematics, and then I have to add these 2 marks, and the sum has to be printed out. So that's my aim. So now this is my first statement. I have my input function, and in the input function I have written enter the marks of physics, so that will be printed out, and now 70 will be entered by the user. But you should know the input function reads 70 as a string, and it is stored as a string into mark 1. Now the same thing happened to mark 2. Marks 90, which is inputted for max by the user, will be read by input as a string, and it will be copied to mark 2. And after that I am trying to add mark 1 plus mark 2. Now the problem here is that mark 1 is a string and mark 2 is a string. So when you use this plus operator between two strings, you remember we will actually do a concatenation, right? So this is 70 and this is 90, so both being strings, and then you just do a concatenation between them. The result is going to be 7090, right? And you can see this is the sum value that you are getting, and you know this sum is completely wrong, because when you add 70 and 90 we were expecting 160, and see the result. Why this problem happened? Because we were working on strings even though the actual data was number. So now we have to convert this string 70 into integers, and then we have to store it inside mark 1. So now you understand we need type conversion. String has to be converted to integer in this case. Now just to verify, after these statements are executed, if you try to identify the type of mark 1, that is over here, you can see it will output as string even though mark 1 is storing value 70 because it is stored as a string. So now let us go forward. So next we are going to study about explicit type conversion, where we will write the code and force a string to convert to integer, or a float to integer, or an integer to string, right? So this is done inside the program code. I will write the corresponding function and force the variable to change the type. So here we have one such example. So we know that the value inside mark 1 is 70, but it is stored as a string. So you can use the type conversion function called int to convert the string 70 into integer 70, and then you can copy that again back to mark 1. So now mark 1 is storing number or integer 70. Now in the next statement you can see mark 2 is having the string value 90. Now this integer function will forcefully convert this string to an integer and then load it back to mark 2 itself. So now mark 2 is having value 90, and that's a number, that's an integer. And after that, when you try to print sum equal to, so that will be printed, and after that mark 1 plus mark 2. So right now mark 1 and mark 2 are integers, so now this plus will work as an addition operator. So now 70 plus 90, the result will be 160. So that will be printed out. And after that, if you check the type of mark 1, you can see it is changed to int. Now you see we have done it the hard way, right? First we collected the input using input function. It was read as a string, and then we used that string with integer function to convert that to an integer and store it again as an integer to the same variable. We can do this in one go, in one step itself. Now let us take such an example. You see this statement. My aim is to store a floating point number 80.4 into mark 1. Now you see what I have done here, right? I have used input function to print enter mark 1, so that will be printed, and after that input function is waiting for the user to make an entry. So now the user will type 80.4. So now input will read 80.4 as a string. But now you can see this entire input function is put inside type conversion function called as float. Now what this float function will do? It will convert string 80.4 into a floating point number 80.4, and that will be loaded into mark 1. So now in this statement I have used two functions. Input function to read the input as a string, and float function to convert that string into float value, and then it is loaded to mark 1. So you can do this both operation together in one statement itself. Now you can see in this statement it's the same thing. 60.7 will be read as a string by input function. It will be converted to a floating point number by float function, and then it will be loaded to mark 2. So now mark 2 and mark 1 are floating point numbers. They are numbers, they are not string. And after, when you try to print sum is equal to mark 1 plus mark 2, it will just add numbers 80.4 and 60.7, and you can see the result is coming as 141.1000. So with this example, I have discussed with you how to explicitly do the type conversion to integer and to float. If you want to convert something to a string, you can use function str. But of course, if you want to read an input as a string, then you don't have to give anything. Why? Because by default, input function reads as a string itself. So you don't have to convert to anything else. But if you want an integer or a float to be read from the keyboard, this is how you do it. Now we are going to see about the second type of type conversion that we have seen before. It is called as implicit type conversion. So this type conversion is actually done by the interpreter itself. So we don't actually call any function or program, or we don't write any code to do this. Interpreter does this in the background. So let us see this example, you would understand. In the first statement, I am storing value 20 to mark 1. So now we can understand the type of mark 1 is int because it is storing an integer value 20. Now in the second statement, I am storing 30.2 to mark 2. So the type of this variable mark 2 is float because it is storing a decimal value. And in the third statement, you can see I am adding mark 1 with mark 2. So right now I am adding 20 plus 30.2, and now I am loading the result to total. Now the question is, what will be the data type of total? Because you can see on the right side, the first operand is an integer, the second operand is a float. So what will be the data type of total? Python has a default rule in this. Always Python will select higher precision data type. So what do you mean by precision? For example, if I add 20 and 30.2, you know the result is 50.2. If I make the data type of total equal to int, then what is the problem? Integer cannot store decimal value. So this part has to be cut off, and total can store only value 50, which is wrong because we lost the precision. So Python interpreter understands this, and Python understands always a floating point value has larger precision than an integer. It will automatically select the data type of total as float. So what is the advantage? Add 20 and 30.2. The result is 50.2, and it can be stored into total without losing any value inside it. This is called as implicit type conversion. The interpreter decided that the total has to go with float so that it can actually store the entire result after the addition. So here you can see if I print the value of total, it will be storing a floating point number. After that, if I print the type of total, okay, you can see the interpreter returns that it is set as a floating point value. Now the last statement is what I have discussed with you now. Here the interpreter automatically selects the type of total variable as float to prevent loss of precision, because if it was an integer, then I can store only 50, and you can see we lost the precision, right? Next we are going to study about debugging. Okay, so debugging is actually a term which is used inside the software industry. Let's say the program that you write as a software. So now what is a software bug? Okay, a software bug is an error or fault in the computer program. Assume that you write a small program for some purpose, but when you run it, you are not getting the proper result, or when you are giving input, the output is not matching with the input value that you are giving. So now you understand your software or program has a bug in it. So you have to correct it. So correcting your software bug is called as debugging. So the process of identifying, correcting errors in a program so that the output matches your expectation for each input that you give is called as debugging operation. Now, debugging is a big term in software industry, which means that all the programmers makes mistakes. So please understand that nobody writes perfect program in the first place. So now that you have started with the journey of Python, in the next video session, we will start to write small programs related to what we have studied until now. So when you attempt those programs, maybe you have some problem, maybe you will hit some syntax errors, or the interpreter will give different kinds of errors. So don't get disheartened. You just have to sit and read your program once again. You will find the mistake and then you have to correct it, and that process is called as debugging. And every software programmer always have to do debugging after he has written the code in the first place, right? Because that's why I told you no code runs perfectly the first time. In order to debug, you have to identify the errors in your program. Okay, errors means bugs, and after that you debug it. Now there are three types of errors in the program. The first type is called syntax error, the second type is called logical error, and the third type is called runtime errors. We will see each of these errors in detail in the coming slides, but just understand syntax error is the easiest to correct, logical error is little bit more difficult to correct, and runtime error is extremely difficult to correct. Now let us see each one of them in detail. Now first let us study about syntax errors. Now what do you mean by a syntax? Rules for writing programs in any programming language, you can call it as syntax. So syntax is not a term which is invented by Python. If you are studying C programming language, you have to study the syntax of C programming language. Right now we are studying Python, so it is our aim to study the syntax of the Python so that we can write a proper code without syntax error. Now syntax error is mistake in the program caused by violating the rules of Python. Okay, so this is why I told you this is very easy to identify, because syntax errors will be identified and notified to us by Python interpreter itself. But the other two errors, interpreter is not going to help us. We have to find ourselves. So next you can see interpreter will stop execution if it finds a syntax error in your Python program. Interpreter will generate an error message. So when you see this error message from the interpreter, don't get disheartened. This is your hint. Right? You have written a big program, and when you try to run it, interpreter identifies a mistake in it, and interpreter is notifying you regarding this mistake as an error message. So when you read that message, most probably you will understand where is the problem inside your code. You can directly go there, fix it, run it again. Mostly your program will work fine. Now, one of the example for syntax rule is unmatched parenthesis, which means you open a bracket, you forget to close it, right? So in this case, your interpreter will give an error. We have some examples coming, then you will understand it much more clearly. These are examples of syntax errors. You see the first statement. I have written 5 plus 3 into 2, so there is nothing wrong until here, but I have used a closing parenthesis without an opening parenthesis. That is a basic rule in Python. The parenthesis has to match. So you see, the interpreter is giving error, syntax error, unmatched bracket. So this is why I told you this error message is an indication for you to understand where is your mistake. So now you don't have to check for all the mistakes that you might make. You just have to check somewhere I have missed a bracket. So only where you have put brackets, you go and check, and somewhere in the program you will find, oh, here is where I forget it, and then you give that, your program will work fine. Now in the second example, you can see I have loaded 10 to A and 10 to B, and after that I am trying to print the value of A plus B, but unnecessarily I used a quote over here. So now this will give a syntax error, EOL, that is end of line while scanning string literal. So once you read this end of line while scanning string literal, you may not understand what it means, but actually once you start coding, you will get to know what are the meaning of each errors. So Python interpreter is saying it has seen a quote. So inside it expects a big line because that's a string. But this line never ends because this line will end only when interpreter sees the ending quote. That is the end of line, right? But here you see there is no ending quotes. So that's a problem. So next we go to logical errors. Logical errors also have another name called as semantic errors. But we will stick to this name logical error because that is easy for us to understand. Now, logical errors are mistakes other than violating the rules of Python. So this is, I would say, logical errors are our mistakes. So we are not making any mistakes with Python rules. I learned Python properly and the program that I have written is perfectly matching with the rules in the Python. So syntax errors is not coming, but still your output can be wrong. Now in that case, you have to think about, do I have any logical errors inside my program? So here you can see the interpreter will not find these mistakes and execution will be complete. So this is where I told you finding logical errors is a little bit more difficult than finding syntax errors, because with syntax errors, interpreter will stop the execution and will give the error message. So we can clearly read the error message and correct it. But with logical errors, the program will run fine, you will get the output, alright? But the output is wrong, you know that. So this must be corrected by checking the code's logic by the programmer. So this is why I told you it is more difficult to correct. With this example, we'll understand logical error a little bit better. Now we see the first option. I'm trying to find the average of these two values, 10 and 20. You know that when you add 10 and 20 and divide by 2, the actual average that I should get is 15. So this is the correct answer. To find the average, first I will load value 10 to A, 20 to B, and after that I'm finding average A plus B divided by 2. Now I will find the result of A plus B divided by 2 and the result will be stored into average, and after that I am printing the value of average. Now when interpreter goes through each line, interpreter will not see any error because all the lines are written perfectly according to the Python rules. So now this program does not have a syntax error, but you see the output. We are getting 20. We were expecting 15 and 20 is not equal to 15, so we have a logical error inside this. So now we have to go, we have to read each line, and then you have to find out this is where my program goes wrong. Now I realize that my logical error is in this statement. So let us see where is the error. If I write A plus B divided by 2 without putting any parentheses, you can see I have two operators here, addition and division. Now according to the operator precedence, you know that division has got higher precedence than addition. So now if you simply write A plus B by 2, the first operation that will be carried out is to divide the value of B by 2, and to that result the value of A will be added. So you can see the value of A is 10 plus value of B is 20 divided by 2. So now initially 20 divided by 2 will be executed. So this will result as 10. Now this 10 will be added to the first 10 and the result will be 20, and that is why we are getting the result as 20 over here. So now that we have identified our logical error in this expression, now let's see how to fix that. Now to fix it, you see this statement, you can write your expression like this: A plus B in bracket divided by 2. So now first A plus B will be done. So 10 plus 20, 30 will be evaluated. Now it will be divided by 2 and the result will be produced as 15. So now you can see if I print average, it is coming as 15. So this is an example of logical error. Now next we are going to see the last type of error, which is called as a runtime error. So these errors are encountered by the interpreter when the program executes. So why this is very difficult to identify? Because maybe when your program runs 1 time, 2 time, 3 time, it will work perfectly. Even the output will be correct. But when you keep on changing the input, maybe in one or two special input conditions, your program will have error, or maybe your program will give wrong result. So that is why we call it as a runtime error. Why? Because your program is syntactically correct. Your program doesn't have any logical mistakes, but based on some input value, some special input value combinations, your program will have problems. Okay, so that kind of problems is classified under runtime error. Now, why this is very difficult to identify? Because you see, I write a program and I give some input, I check the output is correct. I give another set of input, I check the output is correct. So I will assume that my program is perfect. I will send it to many of my friends, and maybe one of the friend, when he give a special input to this program, he is getting an error. So now he will call back and say to me, your program is not correct, right? If you give the input as these two numbers, then your program is not working properly. So one such example is division by zero. For example, if you are writing a program to divide two numbers, okay, so first you take an input to variable a, okay, you can give any number that will be stored into a. Now after that you give an input to variable b, then you find the value of c by dividing a by b, okay, and after that you will print the value of c. Now if this is your program, when your program runs, assume that you enter value of a as 10 and value of b as 2. So now in the third statement, you can see 10 divided by 2. So value 5 will be copied into C, and now it will print the result as 5. You see, my program executed properly, which means there is no syntax error. The output, when you divide 10 by 2, the actual result is 5. My program is finding the correct answer, so we don't have any logical errors also. But this program has a hidden problem inside it. For a special input, it can create a problem. So now let us see what is that. Now I run the program again, and this time I will give value 10 to A. Now for B, I will give value 0. Now to identify the value of C, now your interpreter has to divide 10 by 0. You see, any number divided by 0 is undefined, right? In mathematics, it is undefined. So the problem here is that this will give an error, and this error will happen only when you give value 0 to B. Any other number you give here, it will properly divide. That is why I told you it is very difficult to identify runtime errors, because it will not happen every time. Only for some special input, that particular situation will be created and your program will have issues inside it. So runtime errors are very difficult to find out. Next thing, you see file not found. For example, you write your Python program and this program requires an input file to function. Okay, so for example, this file should be provided to your Python program, then the program can finish its job. So this file, you call it as input.txt. Now when you run this program inside your computer, your Python program will work perfectly because you have this input.txt inside your computer. Now once you have tested your program is proper, now you send this python.txt to your friend, right? Now your friend will take this program and run in his computer. Maybe he will get an error. Why? Because he don't have this input.txt in his computer. So this is runtime error. The program was working properly in my system. So this is an example for runtime error. So this example I already discussed in the previous slide. So we'll just go through now. So here you can see I'm printing a divided by b. The problem is that b should never be 0. If it is equal to 0, then Python cannot find this value. It will give an error. So value 10 is stored into a, and after that into b I'm taking an input, right, and converting that to integer. So now accidentally the user input the value of b as 0. So now 0 is stored into b and I am trying to divide 10 by 0. This is undefined. So now you can see immediately Python is producing an error, and the name of the error is 0 division error, right? And the explanation is division by 0. So this is a runtime error. Why? Because if the user have inputted here 5, this program will work properly, right? It will divide 10 divided by 5, and this print statement will print the result as 2. So with this, we have completed this chapter. In the next video, we will see some small Python programs to reinforce the concept that we have studied until now.